This question asked us about our knowledge of trigonometry as well as the unit circle a little bit. So let's take a look. If the tangent of theta, theta just being a variable for an angle, is equal to -5/12, and theta is greater than pi halves but less than pi, what is cosine of theta? All right, so a few things. First of all, maybe let's talk about these trigonometric functions. So the three that are most common are sine, cosine, and tangent. And usually students are taught something like the acronym SOHCAHTOA, but to find the sine of an angle, it's equal to the opposite side of a right triangle over the hypotenuse. To find the cosine of an angle, it's equal to its adjacent side, the one that's next to the angle, over the hypotenuse. And the tangent of that angle is equal to the opposite over the adjacent. Okay, so we're going to kind of use those three, really just cosine and tangent, but let's talk about this piece. This piece is telling us the location of our angle. It's between pi halves and pi. So if we drew an axis here, it would look something like this. The right-hand positive x-axis is 0, and then this is pi halves. So 90 degrees in radians is pi halves, 180 degrees in radians is pi, and that's really all we need, but I'll finish this off. This would be 3 pi halves, so 1.5 pi, and then all the way back around the circle, back to the start, would be 2 pi. So what this is telling us is that the location of our angle is in this quadrant, the second quadrant. Okay, so if I drew an angle, it's always formed with the origin. So if I drew an angle in here, we could call this right here theta. Okay, and then that makes a right triangle. So if we go straight down to the x-axis and then straight over to the y-axis, we have a right triangle formed here. And that's why we can use our right triangle trig. So we're told that the tangent of theta, and we know the tangent is the opposite over the adjacent, is -5/12. But for now, I'm going to write the opposite. So the opposite side of the angle is 5, and the adjacent side of the angle is 12. But we notice that there's a negative there. So how does that become negative? Well, that's what this quadrant tells us. So if we're looking at the 5 and the 12, and we're thinking about which one's positive, which one's negative, we know that the 5 is positive because it's in the positive y direction, and that the 12 is negative because it's in the negative x direction. So that's how we get the -5/12. The negative is actually assigned to the 12. Okay, but the question asked us for the cosine. The cosine is the adjacent over the hypotenuse. I have the adjacent, the side that's next to. I have the opposite, but I don't have the hypotenuse. Okay, so if you knew the special right triangle 5, 12, 13, we could just write that the hypotenuse there is 13. But if you didn't know that, we could use the Pythagorean theorem, and we could say 5 squared plus -12 squared is equal to, I'll call this h, sometimes it's called r for the radius, but h squared. All right, 5 squared is 25. -12 squared, a negative number squared is positive, so that's 144, is equal to h squared. 25 plus 144 is 169. That's equal to h squared. And then to get just the value for h, we have to take the square root of both sides. So the square root of 169 is 13, and that gives us our value for h. So h right here is equal to 13. Now we know enough to answer the question. We're asked about the cosine. We know that cosine is the adjacent over the hypotenuse. So the adjacent side is the -12. The hypotenuse is 13. So we would write the cosine of theta, which is what we're being asked, is equal to negative 12 over 13. All right, so we look for that in our options. We see the 12 13s here, but it's positive. And then we see 12 13s here, and it's negative. We just got to be careful we don't select that answer because it's flipped. It's got the 13 on the top. So we see that J is the answer that matches our solution.